For my subdivision assignment, I used WebGL and with JavaScript and HTML, so you can view it online. And let me show you my code first. So a lot of this is basic setup. I'm not going to really go into that. It's not really relevant. But here, for the subdivide, it takes in a geometry object, and I'm setting up some variables that I'm going to use later. And my first function inside this function is called createEdge. And what createEdge does is it takes in two indexes from a face, like two face indexes that point to a vertex, basically. It takes in a map, and it takes in a face index itself. Like, there'll be 1,000 faces, and it'll go 0 to 1,000. And first, to make the key, I use mathmin and mathmax to make sure the key is always in mathematical order. So if it's like 0 and 2, it'll always be 0 and 2 and not 2 and 0, which makes it easier to look up. And if the map does not have the key that was just created, we create two vertexes using the indexes, and we create an edge object and store all this information. We can store the vertex, the vector itself, basically, and then the index of the vector, and then the new vert, which is a vector that's going to be the actual edge itself between the two vertexes, and then the connected faces, which gets updated every time. Right here it shows you every time the key has already been used or whatever, it uses this else statement, and it'll push the current face into the face array, so it keeps track of which faces are connected to each edge, basically. And then here's a little for loop that just creates every single edge using the face array of the geometry. So all the edges are now created. So and for every edge, we create a new vertex based off the weights of its neighbors. So this is the part where we're using the 3/8, the 1/8 scaling factor to create the new edge vertex. And basically what I did here was iterate through my map. I have a little storage thing right here that stores right here. Okay, so for each, basically we go through all the edges, and for each, how to describe this? Okay, so we have two constant vertices for each face, and we go through each of the two faces that a edge will have, because every edge will have at least two faces unless it's a boundary case. And if that vertex is not equal to we go through each of the face vertexes, and the one that's not connected to the edges gets pulled out, essentially, and put in the outer vertex. So for the ones that get pulled out, we put the 1/8 scale on them, and for the original two edge vertices, they get the 3/8 scale on them. And if it's a boundary case, we just do basically a standard in between two vectors math, and you get the middle point. And that's for the boundary cases, but for most cases, it's going to have the weights on it. And for the original vertices, we wanted to smooth those, and we used the whole beta and n. And basically what I did here was we have a control index, which is a vertice, and for each vertex we want to find out how many vertices connect to it by an edge. So we just count basically each vertice that is connecting to that control vertice, and for every new one we find, we update. I'm storing it in an array, and then n is basically the length of that array, because each new vertex you find is a new edge. And if n is greater than 3, so if there's more than 3 vertices connecting to the control vertex, we use this beta formula that was given to us on in our book. Else, we just do 3/16, which is lower than 3. And for each surrounding vertex, we apply a weight and add it to a new vector. So we're just doing some vector math, adding up all the adjacent vertices, and then we push it into a new vector array, and then we make the old vertices equal to the new vertices we just created. And here is just a basic for loop that creates all the new faces, essentially. It'll just create all the new faces based off the new edges we created, the updated vertices, and it actually creates the mesh or the geometry. And now we return the geometry, and that's basically how the subdivision goes. This is the code right here that lets me increase or decrease subdivisions using the plus or minus on the numpad, just like the assignment said. And it goes up to 5, just like the assignment said. And let me finally show you my the fruits of my labors. And it only works on Firefox because for 3JS to load the JSON mesh, which is Susan, you have to have an HTTP server, and Google Chrome doesn't have that, but Firefox does. So we just click demo, loop subdivision, and here is the Suzanne mesh using wireframe. And if I press plus, it increases the subdivision. As you can see, the triangle density has gotten much more. The edges have gotten a little bit smoother. I'm going to increase the subdivision one more time so you can see it even better. It's computing right now. Like, my computer's not very fast, so I can't do more than 2 subdivisions on this computer. But as you can see on this subdivision, things get even smoother. The density of triangles has increased significantly, and the outcome is basically what you'd expect from loop subdivision. And let me just go back to the original, and just so you can see everything's all blocky, and after subdivision it looks great. And let me increase subdivision so you can see it one more time. Get a good look. The frames are, as you can see, I guess once the mesh renders again. As you can see, I'm getting 42 frames, which isn't, or 50 frames. No, yeah, 50 frames. So it's not bad. And let me just circle around the mesh so you can see it. Show you that there's no abnormalities. And that's it. Thank you for watching my video, and goodbye.